Hi guys, and welcome to Lecture 6 of the Intro to Backend course. Today we'll be talking about deployment. This is actually quite a thick lecture because we're going to be going over some really important things. Not just for the quote-unquote hack challenge for this semester, but also just in general if you want to be a real backend developer. So let's review what we talked about last week really quickly. So this is just containerization, how to package code into a standardized unit of software, having images and having that run live as containers on the servers, and pushing images to Docker Hub. So hopefully you guys are well acquainted with that. And to jump right into this week's lecture, let's get started with servers. So in the very first lecture, we talked about what a server and client model was. And I feel like it's kind of hard to wrap your head around what a server is, but just as a baseline definition, this could be a software or hardware device. So when you say, hey, I'm going to go deploy my code onto this server, you could mean both in the software and the hardware sense. And this is just a place, or I guess some abstract entity that accepts and responds to requests made over a network. Recall that a client is just a device that makes that request, and the server is what gives that response. And to help you kind of understand what servers could look like in the real world, I have three examples. So first, a web server. This is just something that shows pages and run apps. An example client is like Chrome or Firefox or Safari. These are just web browsers. And then an email server is actually quite common. So Gmail essentially is running on some server, and some client could be, for example, your iOS mail that is connected to Gmail, or it could simply be the Gmail page in the Firefox browser. So you interact with these things every day, but it's, I guess, hard to recognize that, oh, that's a server. And something else that you probably interact with very frequently is an identity server. So this just manages login and security roles. For example, you want to enroll in Student Center for a class, but you have to do that CU web login and duo push two-step login, which is annoying but really important. So that just is essentially you you giving your browser your credentials and then your browser making a stop at CU web login, so that CU web login server itself can authenticate you and then let you know if you can, I guess, go into Student Center properly. So there's a lot of steps involved, but these are just some examples to help you get your head around. But they're not required to know for the course, obviously. And so, what exactly does a server get recognized on the network? And that is the IP address. So, an internet server is assigned some, I guess you could call it a name, and it's what distinguishes the server from others on the network when it gets connected to a router. And a very common example of a router is, of course, the wireless router. So, that is the Wi-Fi. So some of these things are like, okay, I vaguely know, because, I'm a regular citizen of this world, so I know what a Wi-Fi is, but it's hard to put it in the context of the backend world. And hopefully this lecture really clears it up. But essentially you have an IP address, and you also have a domain name. So a domain name could be like google.com or Facebook, without the .com. But every single domain name has a linked IP address. So whatever number, like 324.123.789, that corresponds to some domain name, and something called the DNS, the domain name system server, is what's able to convert that domain name into an IP address. So, for example, if you go onto your browser and type google.com, that Google part is the domain name, and it will get translated via the domain name system server into the server's IP address. And and this is what allows you as a user to connect to Google Server. So those are the bare basics, and there's obviously a lot of intricacies like what the heck, how does the IP address get assigned, and this is just a fun fact, but it's by the INC, the Internet Network Information Center, or an IP address could be established by a web host, just a company in charge of web pages, for example, GoDaddy. And there's a lot more to know about this area, but just wanted to give like a brief overview before we talk about deployment. So deployment is something that's very important if you want your app to be publicly accessible on the web. So let's have a rundown of what exactly our app needs. So it needs to be always running, open to receiving requests from clients. This could be, iOS clients or Android or the browser. It, of course, needs to be publicly accessible on the web, and there needs to be hardware that is managed for us and connected to the cloud. So what this means is you're not going to want to have a massive computer in your room that's running your application for the whole world to see. Chances are you're going to be buying a piece of hardware that's allocated or managed somewhere by a company, for example, Google Cloud. So the main idea is you want to be able to rent this server, not manage this hardware yourself. So again, we want to run our application on the server in the cloud. And that's the whole point of why we have to containerize, because we want to run something that we built locally and put that on the web. So a server that doesn't exist with you physically. And this is very important that it's managed by a cloud service provider, because they provide tools that help automate security, and they can help you scale and help you deal with what happens when your app crashes. Some popular examples are AWS, Amazon Web Services, DigitalOcean. This is actually what AppDev uses for our apps, like Eatery and Ithaca Transit. We use DigitalOcean for our backend servers. Azure and Google Cloud, which you'll be using in this class. So these companies handle physical maintenance of your servers, and by giving you tools for security, scaling, and crash handling, you can focus less on that kind of server handling and focus more on building your application, which is really nice. So something that's very important that I myself struggled with understanding is SSH. So this is a protocol that helps you access a server. So in general, computers talk to each other, and SSH just allows this to happen securely. So SSH is a way that ensures secure transfer of information between a host and a client. So the host is a remote server that you're trying to access, and the client is the computer that you are using to access the host. So the reason why we want to do this is because we want to access that remote server, like we said, that's managed by some cloud service provider, so that we can open and view resources in that server, execute commands, install packages, and update software. So not only do we have to, set up our containerized environment that was nicely packaged before, that we talked about in our last lecture, onto this server, we might have to manage new things. Like, for example, if I want to update a package, I would SSH into that server to update it. Because that server is what's managing my app and running it publicly. So if SSH is very confusing, don't worry about it. Feel free to ask questions on Piazza. This is actually quite an important concept, not just if you decide to be a backend developer in AppDev, but just in general, because it's like one of the basic ideas of authentication. And so let's actually show you guys a screenshot of trying to connect to a host. So as you can see here in the command line, we have SSH in green because it's a keyword, and a tag -i with its parameter server.pem, appdev at eatery backend cornell appdev.com. So let's break that up for a sec. So -I is a tag that takes in an identification file to use for this public key authentication. And the public key is what allows you to establish that secure connection between the computer that you're currently using and the remote host that you're trying to access. And usually the file location is assumed to be in the current directory unless you specify a relative path. So it's common practice that you have this identification file in the root of your computer, because it's assumed that, if you're an admin, you'd be able to manipulate stuff in your root directory. And then you see this server.pem. So this is what includes a certificate. It could simply be just a public certificate like an Apache install, or an entire certificate chain, which could include the public key, the private key, and root certificates. So don't worry too much about this, but just know that this is some secure container format. PEM actually stands for Privacy Enhanced Mail. So the name came from that, which was a failed method for secure mail, but the container format it used lives on, and that's why we call it PEM today. It's one of the many container formats for SSH to use to authenticate. You can think of it as just a standard or a way of encoding data. And the PEM certificate itself can end in a variety of formats like .pem, .key, .cer, .cert, and a lot more. So that was something where I would used to use and not know what exactly I was using. So it's always good to break that down when you start learning this stuff. And of course, Aptiv at eaterybackend.cornellaptiv.com, that itself is the host that you're trying to access. So if I was a backend dev for the Eatery app and I wanted to update our servers, I would do this command in my command line to enter into that remote server and do my updates. So how this works is you provide username and password credentials. It's going to be a unique public key pair, and it helps to authenticate between the local and remote servers. And it needs to be generated to automate login. And in general, I think what's most important that you know is that a host key is a cryptographic key. Cryptographic, who knows, that is used for authenticating computers in the SSH protocol. And host keys are just key pairs, and this could be generated from RSA, DSA, or ECDSA algorithms. These are just ways to hash your sensitive information, and also generate keys to authenticate yourselves. And public host keys are stored on SSH clients and private keys are stored on SSH servers. So if you know this kind of basic information, it will make sense later when we talk about other things. But let's move on to SSH in action. So as I was mentioning before, you have an SSH client that stores the host keys, and that's why you might have something on your computer called known hosts. It's like some file that keeps track of all the hosts that your computer has ever connected to. So when you're trying to SSH into a server, your computer, if it's been able to secure a connection with the remote server, will add that server's key into this file called known hosts. So it's remembered. So the next time you can connect, it's, I guess, automatic. Don't worry too much about this either, but it's just like general important knowledge. And if you are authenticated successfully, the command prompt for that remote host that you're trying to access will open up so that you can interact with it and run your code, update whatever you need to do, blah, 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 etc. So in this course, however, we're going to skip over this SSH business because it's a lot easier to just use Google Cloud's web terminal, and this is just some command prompts that opens up over the web. So essentially you would go into Google Cloud and you like click some button that literally says SSH, I think, and it just opens up that terminal for you already without you having to deal with SSH and stuff. And we do this because it's a lot easier for people who are just getting started with deving apps. So that is it with authentication in terms of trying to access a server. But let's move on to how we want to optimize running our apps on servers. So a major idea is clustering. So what is clustering? It's making a group of servers behave as one system so that each server can be optimized to do one thing. It's kind of like it's hard to make one server do a bunch of things, but if you give it one thing and it knows how to do it, it can do it really well and fast. And if anything breaks down, you can pinpoint the issue and go and fix that. So this is just the best way to make your system work. And note that this is not to be confused with containers. So containers, multiple container server is essentially multiple images running on one server. But here we could be designating a server for a purpose, so this would result in multiple servers. Now here's a nice visual showing one server with handling multiple features of an application, which could be the application itself, as well as managing a database and having a storage system just handling manual files. But if you had clustering, this would be having a server for each of those. And essentially, you're having multiple hardware as per each server. So to break it down, each server would have one purpose, one being running a web app, which is what we've been doing, operating an entire relational database management system, and another one just handling the storage of freeform data like random files. And before, if we had all of them on one server, the server wouldn't be able to do any of those optimally. But in industry, actually, service providers like AWS have different servers dedicated to each aspect of the system, just like what we're showing here in clustering. They have different instances for running different things. You might have heard like EC2 instances or RDS instances or S3 buckets, kind of like these buzzwords, but they're essentially just different servers for doing different things. And you can go on the Backend course website to read up more on these details, but they're not too important. Just know that clustering is a thing. And the benefits are that by delineating these specific roles of the servers, the cloud computing services that we mentioned earlier, like AWS and Google Cloud, they can optimize each server to perform their designated task. And if these are all connected properly, you can actually create a better performing system and something that's resilient. So if anything breaks, it can come back up easily. And as an example, for the Ithaca Transit backend, if the server crashes, the server can just help me bring things back up. I don't need to be sitting at my computer waiting for anything to go wrong so that, I can be immediately available to fix those issues. And by separating roles, you can also add in more things to your application easier. For example, if you wanted to add more operations or net storage size or add a new aspect of your app that requires storing a new file type, or if you need to be able to handle increased user traffic, that can all be doable if you have this system where each server does its own thing. So it's scalable, and it also introduces something else called load balancing, which I'll talk about. So this is just an extension of clustering. It's essentially just having many servers run the same web app. You might need this if something goes wrong and you can't afford any downtime, so that's when you would rely on your second instance or your second server that's running the same web app. For example, sorry to bring up example of transit all the time, but we have like 8K monthly active users, a couple K daily active users, and so we're getting thousands of requests all the time on our servers. So we have two instances of a server that computes routes from point A to point B, because if one of them gets overcrowded with way too many requests, the second one can handle that. And so in the case of, if you had like a really large scale application, you would have a server whose literal duty is just to reroute requests to each of the many servers. So in this example, we have 3 web servers and 1 load balancer. So essentially what you're doing here is lowering the load on each server by a factor of 3. And what the load balancer does is it just reroutes traffic wherever is necessary. So that's a nice visual. And in the case that we have a really big increase in user traffic, we can automate the process of spinning up new servers to give the load balancer more options to split the load. This allows us to give super speedy responses to clients. All right, so that concludes our lecture for this week. Next week, we'll be talking about authentication. Connor will be going over what HTTP basic, session, and token authentication are. Last semester, we didn't go over this too in depth, so this semester we'll be adding more onto it, which is always exciting, so be excited for that. And as usual, if you guys have any questions on Piazza, feel free to ask. Good luck on this week's assignment. It's actually quite a lot easier than the previous assignments and a lot faster to complete, but nonetheless, good luck and have an awesome week.